name is Ratan, and this is your 13th pre-class video. In this small pre-class video, we will discuss about functional programming in Java, how to achieve functional programming using lambda expression in Java, and we are going to see that one small overview about the stream API as well. So let's get started. So first of all, we are going to talk about the functional programming. What is a functional programming? Basically, we have seen earlier already. That means there are different types of paradigms are there to develop a particular application or to develop a software application, like object-oriented programming, functional programming. So these are the functional programming is one of the paradigm to develop a software application. In computer science, functional programming is a programming paradigm where programs are constructed by applying and composing functions. That means functions, by using that you are going to decompose your main problem into the functions, into the bunch of functions you are going to decompose your problems. Like in object-oriented programming, you decompose your problem in the term of object, but here in the term of functions. In functional programming, functions are the treated as first-class citizen. That is the main important thing, is what function only, and meaning that they can be assigned to a variable, passed to a function argument, another function, and can be a return to another function. That means function will be treated as a value, so that you can assign to a particular variable, you can pass that function to a particular function and return from one function to another function as well, just like that any other data type. Now to work with the functional programming in Java, we need what? Functional interface. We need functional interface. And this functional interface, basically functional programming is started from Java 1.8 onwards. Java 1.8 having the feature called lambda expression. Lambda expression, using which you can perform this functional program. So with the help of functional interface, we can achieve functional programming in Java using lambda expression. So functional programming, we have seen that what is the meaning of functional programming, where functions are treated as first-class citizen or as a value. And we can achieve this functional programming by using functional interface and lambda expression. So using lambda expression, we can represent the object of functional interface in much more concise way, like that. What is the stream API? Later we are going to discuss about that. So let's first see that what is the functional interface and how lambda expression will gonna achieve the getting the functional programming in Java. By using lambda expression, how we are going to achieve functional programming and how we can perform functional programming in Java. So first of all, what is the functional interface? Listen, any interface if you are creating. So I'm going to create one interface. Let's say that if I will create one interface X, and if any interface which is having only one abstract method, that interface can be considered as functional interface. Functional interface means what? Any interface which is having only one abstract method. Only one abstract method is known as functional interface. As simple as this. Only one abstract method. An interface from Java 8 onwards, we can have a default method as well with the body. Void function 2. We can have a static method as well. We can define n number of default and a static method. It doesn't matter. That means we can have any number of default or static method, but abstract method should be only one. Then only it will be considered as functional interface. Now, through give the guarantee that compiler, if you want to sure that, make sure you have written the correct functional interface, there is one annotation you can apply over here, that is functional interface. This annotation ensure that this is the correct functional interface. So if I just try to put any other abstract method, now what will happen? See here, it will started giving problem because this interface is no way longer of as a functional interface. So it has started giving a compile time error. So this annotation belongs from lang package, just like your override annotation. It will make sure that your interface is a functional interface. That means functional interface should have only one abstract method, but it can have default method, default void function 2. Yes, we can have with the body. Still it is a functional interface. You can have a static method as well. Still it is a functional interface. But as far as concerned an abstract method, it should be only one. only one. Then only it will be considered as functional interface. In Java, we have a number of functional interfaces are there already, predefined interface. You might have worked on that. That is java.lang.comparable. Comparable. So that comparable interface to specify the sorting technique within a class, we use comparable. It has only one method, that is only one abstract method, public int compare to object. So this comparable can be considered as functional interface. We have java.util.comparator. It has also only one method, public int compare, and it takes two object o1, object o2. This interface also can be considered as functional because it has also only one abstract method. You might have worked on that java.lang.runnable. That is, it also have only one abstract method, public void run. This runnable basically used in a multi-threading. We are going to discuss about that later. So inside the multi-threading, we use this runnable interface. This is also having only one abstract method. So this type of interface can be considered as functional interface. Now, what is the importance of this functional interface? What is the significance of this type of interface which is having only one method? Now, see here, I have defined one functional interface. Let me revert it back. And I have defined only one functional interface, function X. So let me change that one here. I'm giving the name as this interface having, I'm putting only one method. Let's say that void say hello. I'm taking a string name. So this is only one first abstract method in this interface. So you can say it is a functional interface. Now, if I have an interface, what I need to do, interface mean to be implemented. So what I need to do, I can take a class, let's say that X IMPL, you can give any name, and inside that I need to implement this X interface. Okay, after that we need to override that method. It's the basic rule. If you are going to implement an interface, you have to override this method. So I have overridden this method, and I'm simply printing system.out.println. I'm greeting that particular person, which person is going to supply over here with a welcome message plus. So this is the implementation. So this is the interface which is having one method, and this class is implementation class of this interface, which has overridden this method. Till now we have seen this point. Now what I can do, I can pass x1, which is my interface. I can take a variable, and here which value we can assign, two value, either any implementation class object or null value. So I can easily write here what, new x IMPL, because X IMPL class is a implementation class. So you can say that interface object means we are indirectly referring what, its implementation class object. So whenever you see the term interface object, you have to think it is its implementation class object. We are talking about its implementation object. So we can call it here what, X dot function, or say hello, and pass any name here. Let's say that Amit. And if you run the program, see the output as expected. It will run the program and show the welcome Amit as output. So welcome Amit. Now the thing is that we can, here what I have done, I have an interface. To provide the implementation, I have taken one external class, and then after I have applied the external class object over here. But we can skip this external class as well. There are approaches are there. Before lambda expression, we have the approach of anonymous inner class. Using the anonymous inner class, we can avoid this implementation, and that means this implementation class we can avoid. How? Let's see that. So this is using what, external class. I'm gonna take another approach to avoid the implementation. So what I'm gonna do, let me just put that. So here what I'm going to do, that I'm going to take the new approach, and this is called anonymous inner class approach. So this approach is what, using external class, and this one I'm gonna using anonymous inner class approach. So I have taken one another variable x2, and here see that how I'm doing that. New x. If I do like this, it will give a compile time error, because we know that interface we cannot instantiate directly. Interface, it is not able, we are not able to allow to instantiate this interface. But what I'm gonna do that, after that, remove the semicolon, and instead of semicolon, I'm giving this curly bracket, and here I'm putting this semicolon. This one curly bracket will be treated as anonymous inner class. It will become a class which the class doesn't have any name, and that class will be considered as implementation of this X interface. So see here, if you put the cursor, it is saying that it is an anonymous class derived from X, must be either declare abstract or must implement the method. So what to do, if you put the cursor and if you click on that here, implement method. So whether your normal class or whether anonymous class, if it is implementing an interface, it must override the abstract method. So let me repeat it once again. So here, to define an anonymous inner class, we just need to remove this semicolon and take a body. This body or this curly bracket will be treated as anonymous inner class. Hit that one and you can write a number of logic. And here put a semicolon. So this is your anonymous inner class. Inside that, you need to override methods present in this interface. So let's override the method, put the cursor in this here X and implement method. So only one method is there. So override that. So here we can write whatever you want. You can implement that. So I'm writing here system.out.println hi plus name. So this is the another implementation. This implementation is done using anonymous inner class. And what I can do, x2 dot say hello, and I'm passing that here any name. Let's say that like that. Now see the difference here. This is using external class and this is using what, anonymous inner class. In this case, I need not write any external class. Here itself, I can provide the implementation of this interface. So this one will be treated as object of your X. That means X interface. This is using what, anonymous inner class. But from Java 8 onwards, we can shortcut this anonymous inner class. We can write it in much more concise and compact way. If your interface is functional, you can use lambda expression. Let me write that using what, lambda expression approach. Lambda expression approach. So I'm taking here x3 and see that how I'm writing this implementation. So this interface is having, in lambda expression, this function name doesn't matter. One parameter is there. So name is a parameter. So I can write a string name and then one lambda operator, and then this is the body. This is the three thing you need to do that one using lambda expression. And here you can write whatever you want to implementation. That is, here I'm writing good morning plus name, as simple as this. Now this is your using lambda expression. But wait a moment, we can shut down this code again. We can shut down this code here in lambda expression, even though you can specify the type of your parameter, but it is optional. You need not give the type. Still it will work. Next thing is that this variable name also could be anything, just it will automatically match one parameter. If you're having the interface, see that only one parameter, automatically it will detect it. This n will be considered as name, because here only one parameter is there. Not only that, if you have only one parameter, in that case this small bracket is optional. You can skip this small bracket. Now furthermore, what to do here, I need to, this n is a parameter, so we need to write this n over here. Now if you have only one statement, then this even that is also optional. This curly bracket is also optional. If you have multiple statement, then only that curly bracket is required, and this is your implementation. That's it. You can compare this approach using this approach and external class approach. See that only one statement, that is n, and this is your implementation of functional interface. Functional, because it has only one method functional interface, this x is having, so this one will represent the parameter, one parameter, and this will represent the body. And if I call that one here what, x3 dot say hello and pass any name, let's say that Ravi, and you'll get the proper output. So you can compare this lambda expression approach using anonymous inner class approach and even your external class approach. So let's run the program and see that all three output will be there. So here using external file, using anonymous inner class, and using lambda expression. So this is as simple as that. Lambda expression, if you have taking only one parameter, let me just put two parameter here. If I give here what, name as well as age, let's say that int age. In that case, it has started giving problem because this method is not a valid method. So you need to override over here also. So for the time being, I'm just gonna remove this implementation class, not required. And even I'm going to remove this anonymous inner class as well. Just I'm using lambda approach. Now see here, since I have taken only two parameters, so this implementation will not gonna match because I have taken one parameter. So I need to define another parameter as well. But one problem is there, if you have more than one parameter or zero parameter, remember, more than one or zero parameter, in that case this small bracket is mandatory. This small bracket is optional only when you have only one parameter. But if in case zero or more than one, in that case this small bracket is mandatory. So here a will represent your age, n will represent your name. I have not need not specify that type, need not specify that. It will automatically will gonna detect. And if you want to print multiple statement, in that case also this curly bracket is also mandatory. So curly bracket is also mandatory, and here you can write good morning, this message, and another statement. If you want to print, you can simply write like this, that is your age is like that. Now in order to call this method, so you can pass Ravi and age 25. So this will the implementation. So if you have more than one statement, this curly bracket is mandatory. But if you have only one statement, then this curly bracket is optional. If you have one parameter, then this small bracket is optional. But if you have multiple parameter, then this is small bracket is multiple or even zero, this multiple, this small bracket is mandatory. For example, if you doesn't have any parameter, now in that case, you cannot skip this small bracket like that. Zero parameter, in that case also, this is mandatory. It will be mandatory, and you can write this implementation as your wish. So here, good morning, and here you can give any name. Let's say that Amit, and here age 25. So in case of zero or more than one, you need to pass this small bracket is mandatory, and you can call your method as it is. This is a way you can use the lambda expression. Let's talk about that method which is having a return type. So if you have a method like return type, suppose that a method, suppose get or get addition, and I have two parameter, int num1 comma int num2. So I have this type of method. This is also can be considered as functional interface because it is only one abstract method. Now how to define the implementation? How to define the implementation of this type of method? So see that as simple as that, two parameters. So in this case, this small bracket is mandatory. N1 will represent number one, N2 will represent number two. And this is your lambda operator, and then specify the body. So what I need to do, I need to take int result is equal to n1 plus n2, and then return result, because it is having a return type int. So this implementation must return a particular integer, and this is your implementation. This is your implementation. Let's call the method. So system.out.println x3 dot get addition, pass your value, let's say 50 comma 60. So run the program and you will get the proper output. So this is the way you can implement a method which is having a return type, But wait a moment, you can make it much more shorter. What is that? You can simply skip this line and return, what is that? N1 plus N2. N1 plus N2, and it is a valid implementation. But I told if you have only one statement, then this curly bracket is optional. But remember this point here. Here return keyword is there. But if you skip this only one statement, this is optional. And now I have only one statement. And if you have only one statement and which is a return value, then this return keyword is not allowed. Return keyword is not allowed. That's fine. If you are taking this curly bracket, now you can write multiple statement and here your return keyword is allowed. Return keyword is allowed. But since only one statement, this curly bracket is optional. And if you are not taking this curly bracket, this return keyword is also not allowed. Now see the implementation. See the implementation of this interface. Just only few characters. This will become an implementation. This is a implementation of this functional interface. How short it is, like that. So that is N1 and N2, it will gonna return N1 plus N2. And it still you will get the proper output. So if I'm change the value here 50 and 50, I will get 100. So this is the 100. Now by using this lambda expression, we can represent the object of this functional interface. So if it is a functional interface, this will gonna represent the object of this functional interface. So wherever this interface is required, you can pass this value. So suppose that if you have a method which is going to take that interface. So if I have a particular method, let's say that public int and function one. I'm taking this method is a static method, function one. And we know that we can take a parameter also as an interface. We can take a return type also as an interface. So I'm taking x1. So here this function one is having a method which is a parameter x1. Now in order to call this method function one, what to do? Since it is a static method, I need not pass any what? Function one. I need not create an object and I can simply pass here x3. We can pass the x3 because x3 is a holding the object of this implementation. So here x, it is expecting an interface object, that means implementation of this x, and I have given the implementation using lambda expression. So this is the implementation, put that in a variable and pass this variable. Even what we can do, we can even make it much more shorter. We can take directly, we can pass this lambda expression over here. That means here, this is as simple as that. So we can pass this lambda expression, that means this function, to another function as an argument. So this will become a implementation of what? Your functional interface. Not only that, if your function having a return type as an interface, you can return this entire expression as a return value. I told that in functional programming, functional interfaces, by using that you can represent using lambda expression, you can represent the object of the functional interface, and functions will be treated as an value. So we can assign to a variable. Here this is a variable, you have assigned a function. Here a method, I have passed another method, another function, like that. In Java 1.8, we have a number of functional interface came. That is what some interfaces. But before moving on, there is a one concept called method reference. This method reference, what you can do, it is a much more shortcut. It will the another level of shortcut of what? Lambda or functional interface, or you can say that shortcut of lambda expression as well. What is the meaning of that? Let me show that. So imagine I have a functional interface and it has having only one method. Let's say hello. and here is string name. Now imagine I have another method. Inside this class, I have another method, public void, and let's say that and this method I'm taking as a static method void, and this method name I'm giving function1, function1. This is a different method and which is having one string parameter s, and it is gonna print something like that. This is inside function1 of main class. Now see here, if I want to write, this is the ordinary static method. This is the ordinary static method of main class. It is nowhere related with functional interface. It is nowhere related with what your lambda expression. It is a ordinary method. This is the static method. And now suppose that I want to give a implementation of this functional interface. So this functional interface is x1. We have just now seen that we have various way to provide the implementation. Either we can take external class, either we can take anonymous class, either we can take a lambda expression. Using lambda expression, what would be the implementation? We can write like that. So here it is a return type is void, one parameter is there, So what to do? You can take one parameter, so a small bracket is optional. So n will represent one parameter and you can write that statement. Whatever you want, you can write like that. Inside function1, or you can say that inside method using lambda expression. This is the implementation, and you can call x dot say hello, and whatever the name you are going to pass. So that name, let me print over here also. I'm concatenating this n. So let's say that I'm passing any name Ravi. So it will gonna print inside method using Ravi. Now, nothing great here, but what we can do using method reference, instead of defining this implementation of this functional interface, what we can do, if you have another method defined in any class, which is going to match with this method, gonna match with this method. Matching means what? Return type should same, parameter should same. Only that two things. Method name doesn't matter. Just return type if it is matching and parameter if it is matching, then what you can do, instead of writing this implementation using lambda expression, you can refer another class static method here as a implementation. As a implementation, you can refer that. So what I'm going to do that x2 is equal to in a main class by using this double colon. There is a function1. So I'm saying that please refer the function1 of main class as an implementation of x2. Please refer the function1 of main class as an implementation of x2. That is here, this is the implementation because it is also gonna have the same signature. So here I'm saying that I'm not writing any implementation. That implementation is already, one type of implementation is already defined, which is gonna match with this one. So instead of defining that, you can refer any existing class method as an implementation. So now you can call x2 dot say hello and you can pass any name. So here inside method using lambda expression n, and here inside the function1 of main, and you can print here s also because this is your parameter. And in that case, both case your say hello method will be called. Let's run the program and see that. Here is inside method using lambda expression and inside the function1 of main class. And both your implementation is implemented. That means it is printed. So here x2, this is using that method reference. This is called method reference. Method reference, you can refer a static method, you can refer non-static method as well. Static method symbol is class name, double colon, and function1. That means please refer this function as an implementation. So imagine if you have any other method which is having 1000 statement, But if the return type and parameters are matching, you can refer, need not write this method once again, you can refer that method implementation. Imagine this method is what? A non-static method. Non-static method. This method also you can give the reference. You can also give the reference, but the symbol is little bit different. Here, that means the syntax is little bit different. To refer the non-static method, you need to refer through the object. So what you can do, you can create object m is equal to new main, and then you can refer m double colon function one. This is using what? Non-static method. You can refer non-static method. You can make it, this line is optional. You can directly write here what? New main. This is your object, and on the object I am referring function one. Function one. This is the way to refer the non-static method. Not only that, even you can refer a constructor of a class as well. Let me put a constructor main, and it is a parameterized constructor. Suppose that if it is a parameterized constructor, and I am writing here what? Welcome, and something implementation I have written like that. Okay. Now, as we know that constructor is having by default return type void. That means it doesn't have a return type concept in constructor, but here parameter, if parameter is matching, then you can refer a constructor of a class as well. So how to refer a constructor? By just using what? That is main class having a constructor. So this is a syntax of referring a constructor. So I'm saying that new will refer the constructor of this main class, and if it is having the same signature, whatever having, that means the parameter list is same, return type is void, it will gonna match with the constructor. But imagine if your function interface here, if you have a function interface having two parameter, let's say that int age, now it will give a problem. It will give a problem. It will say that, sir, it is not a valid. This constructor is not matching with your lambda expression method. So you cannot refer this one. So you can, by using this, if it is matching the parameter, then you can refer the static method, non-static method, even a constructor of an existing class as an implementation of your functional interface. Functional interface need not write your implementation by using any mean. That means either lambda expression, either anonymous class, or any external class. So if you want to refer, you can refer an existing class method as well. Now, after that, we have a concept. There are a number of interfaces are there in Java 1.8. They have given there mainly four interface, like predicate, like we have another interface like consumer, we have an interface called supplier, we have a function called interface called function itself. So function itself. So we have this type four interfaces came in Java 1.8 in a package java.util.function package. Function package, these four interfaces introduced, and these all interfaces are functional. That means they're having only one method. Only one method is there, and by using help of those method or those interfaces, you can perform functional style of programming, functional style of programming on collection of object. Now there is a one concept called stream API in Java. What is the meaning of a stream? Let me show that here. So Java 8 stream API. This API is introduced in 8, and this API belongs to java.util.stream package. This stream API is used to process collection of objects. A stream is a sequence of objects that supports various methods which can be pipelined to produce a desired result. What is the meaning of a stream? I have drawn one diagram over here. So stream means what? Suppose that if you have a collection of object, this is a collection of object which is having multiple objects are there, and if you want to perform some manipulation or any modification in these objects, then what you can do, you can insert a pipe like that is a stream. So from here your object will gonna flow, and in this pipe will represent your stream object, and you can perform various operation in a functional style, like you can filter some element, you can map some element, You can aggregate all the element. You can attach another stream to this stream as well. So lots of functional style of programming you can perform on a group of objects. So if you are wherever a group of objects, you can attach a stream, and then automatically the data will start the flowing. And in that flow, you can perform n number of operations like filtering the element, like processing the each element, like mapping one element to another object, like aggregating the element, like counting the element, how many elements are there. Lots of operation you can perform in functional style, So stream package contains some library classes and interfaces using which you can perform functional style of programming on a group of object or a collection of data. Now, some of the features of the stream is there. The stream does not store the element. It only represent element in a sequence. So this stream is like a pipe. It will not store. It is just like a wire. From wire, current will go, but wire does not store the electricity. Just it will represent the flow of data. So it just represent the flow of or element in a sequence. But just like that example, wire does not store the electricity. It holds only objects. Primitives are not allowed. Operation filtering performed the stream does not modify its source. That means if you do any modification, let's say that filtering or mapping or any kind of operation you are doing that over here, it will not modify your source. Your source object will be intact. Intact, it will not modify the source. So filtering a stream object obtain from a source produce a new stream, which with the filtered element rather than removing the element from the source collection. With the help of a stream object, we can perform various type of operation on the collection of object in functional style, like filtering some element, transform the element, manipulate some element, sort the element, etc. So the element stream are only visited once during the lifetime of a stream, and a stream must be generated to revisit the same element from the source. So here, if this stream is gonna consume, then this stream is wasted. Now, in order to get the another stream, you need to insert another pipe, and you can get the data. That means stream need to be consumed. There are some terminal methods are there by using this stream will be consumed. And once this stream is consumed, you cannot reuse this stream once again. Let's say that if you want to filter, so if you just filter the stream, then and you collect the another stream, then what will happen? This stream will not gonna, so here the data will be there. So another stream will come, and this stream will not be gonna reused. So it will not gonna be reused once again. Now, from Java 8, collection interface provide collection interface, that is the top of the hierarchy, one method to get the stream object. The method name is stream. Just to call the method, it's small, it is a method. If you call the stream method, since it is in the collection, you can call on any collection object. Let's say that array list, linked list on any collection class object, you can call stream method, and it will return the stream. Stream is a what? Main. The main interface of this stream API is this one. The stream API having the main interface, that is a stream. The stream interface. Stream is an interface. It is the main interface of a stream API. And how to get this object? By calling stream method on any collection class, because this method belongs to collection interface. So you can call this method on any collection object. You will get the stream interface implemented object. Stream is an interface. Now we can stream will be a generic type. So stream of string will represent sequence of a string object from a source like collection. Stream of employee, that means sequence of employee object from a source of collection. So its stream is having method of the stream. There are two types of method. One is the intermediate method, one is a terminal method. Intermediate method will return a new stream object. So if you call the any intermediate method, instead of consuming, it will return another stream object over there. It will return another stream object, and from there it is called intermediate method. It will call what? Intermediate method. It will return another stream. They will never give the final result. Intermediate method does not give the final result. Like map method, like filter method. See the return type, stream. That means the stream dot call your map method, it will return the another stream. If you filter, it will return the another stream. Now, there is another type of method, terminal method. This terminal method is like a consumer. Once you will call this terminal method, it will gonna consume your stream. So there are a number of the terminal methods are there. This type of terminal methods are there, like for each method, collect method, min method, max method, in any match, all match, count method. These are the terminal method. They will going to give the final result from the stream. That means they will going to consume that stream. They will going to consume this stream. And once this stream is consumed, you cannot reuse this stream once again. This is the way how we can use the stream and how we use the functional program. Thank you for watching.